All right, I think we can start. Can you hear me? Well, perfect. Thank you. Hello, everyone, and thank you to my session, Building a Collaborative Text Editor Solution. I'm going to tell you all about that one, but before, let me present myself. I'm Mihaela. I'm a senior software architect at Systematic, and this is actually a Danish company, even though I work in Romania for Systematic. And there, I'm contributing in designing and building software for what we call the domains where failure is not an option. And I know that this phrase sounds like Apollo movie, but it's true. And that is because we are building software for defense. I'm working on building software for defense. And I'm telling you this because most of the decisions that I'm going to present today in building this solution are expected to be under constraints because of the domain, because of the defense part. So we weren't in the position of asking a guy build this for us. So this talk is not, it has nothing to do with AI. This I'm telling you from the very beginning. And besides being a software architect for Systematic, I'm also a teacher at the Faculty of Cybernetics and Informatics in Bucharest in Romania. So, today, taking into consideration that most of the domains have already migrated all of their data and workflows online, including those from defense, they couldn't just stand still. The expectations was that everyone can simply work together in real time, especially when it comes to editing documents. And in a military field where there are a lot of bureaucracy, there are plenty of documents and decisions that need to be documented, tracked, approved, documented with pictures, videos, and so on. As such, we were given a task that sounded complex: build us a collaborative text editor that will work in an air-gapped environment, in disconnected environments, because those were our restrictions. Our application doesn't run in systems or in environments where we have internet connectivity. We transfer the data via some interoperability protocols to avoid all sorts of problems and data being captured and so on. And because we have multiple servers that are brought together, so imagine a load balancing solution, but when one of the servers can simply go offline for months. And when it's connected back to the network, well, those previous documents that were edited, they do need to be merged together and have the latest version, because those disconnected environments also did some changes. The others one that were online kept updating the documents, so we needed to merge them. So this was pretty much the scenario that we were supposed to build. So for us, it sounded like build us a Google Docs document solution. I'm giving this example because we all know about it, but embedded into our own application, with at that point was a huge monolith with a bunch of microservices and micro frontends, but with a lot of legacy code. And not only to do that, but also build a lot of security layers on top of them, because I'm not only speaking about the regular security workflows that we implement and how to call it, just use privileges and roles and the basic stuff. We are also dealing with security classification clearance for those users. So we had a lot of layers of security to build on top of our embedded solution. So with this in mind, let me walk you through what I'm going to provide today. First of all, I will briefly touch about the context, so which exactly are the users, so that you can have a better picture than even better than I just provided in terms of who uses this sort of solutions. Afterwards, I will explain a bit what exactly it is a rich text editor, because the use case sounded pretty much something that exists on the market. Why not just pick up a solution that already exists? So we had to build this in-house. So we had to define all the concepts that were involved. And I also provide the basic definitions that helped us to achieve that part. Afterwards, I will focus on the collaborative editing part, because this is the main core of my presentation. And lastly, I will speak about the additional requirements that came with this use case, because we didn't just receive the specification of having a collaborative text editor where a bunch of users from multiple servers can work together in real time. We also received a lot of other requirements that made our task even more complex, and also how we managed to address each of those additional requirements. And at the end, if you have more curiosities, I'm here. So let's get started. And I said that I can provide some details about the users of the application of this collaborative text editor solution that I'm going to present in the next hour was through some pictures. And yes, these are some real pictures with our application. You can see them, you can see it in there. And our users are those that are performing their tasks, if I can use this word, either on land, on air, on sea, or from a simple command and control centralized server. So these are the users of our application. And what they all have in common is the fact that they all participate in a situation or a workflow similar to ours in development, because before they start performing or executing any task, they have something called a planning phase. And within this planning phase, this is the moment where you have most of the documentations. Everything from the structure of the organization that will participate in certain missions, from the assets that belong to them, details about the target, the location. So everything is captured within those documents, and everyone must have access in real time to what is written in there. And if someone adds a video from the field with something, a link to it, then everyone else should have access in that exact moment, so that it has all the bases necessary to take the decisions. And now I will put even more on top of this, because I have a bunch of users, and these are from different places, and they have different ranks. As you can also spot them from the pictures, they are dressed differently, so they have different security clearance levels. And the security clearance levels, in our case, applies not only to the document itself. So someone that is, I'll put a random name, top secret, has access to all the documents. But if it's someone upper or lower than that one, maybe doesn't have access to all the sections from inside the document. So we needed to make it more granular to be able to set those accesses to specific paragraphs, to specific links, to specific pictures, and so on. So this is the granularity we were supposed to introduce and embed in this solution. And now, more than the users, I'm going to share some pictures that shows different deployments, because some of the users are using the application from a laptop, from a PC, from a tablet, from a mobile device, or maybe from a hand device that the military personnel are using them on the field. And there could be also, I have a couple of tanks and other military vehicles over there. Our application are installed on special servers that are running inside these vehicles. So all of them are, and I forgot to show you the cloud part. We also have this application in our own solution for cloud. So all of them, no matter from where they are accessing the application, and even more, no matter from which version, because we have a compatibility period for 2 years of maintaining compatibility between documents or the collaborative editing solution that we had 2 years ago and the one from here. No matter which update we are making in the meantime, we do need to make them compatible. So no matter from which device, from which type of deployment, or which version in between this gap, obviously, they must work on the same version, and everything needs to work. And if something was missing, for example, 2 years ago we didn't have tables. I'll give a simple object as an example. If we didn't have tables, we need a way to figure it out, how to map a table that exists in a newer version of the document, and how we are going to display that empty space, or at least the information, in a way it makes sense in an older version. And yes, all of them needs to have access on the same document, and if someone makes changes, all of the changes must be brought to all the users. And therefore, as mentioned, we needed to build this solution in our own application, and we had to respect our high standards for security, for quality, and most importantly, the part of the security, not just to mention the quality and the performance part. Security is very important in this field. So, I mentioned that I will provide some details about what exactly each or each text editor, because before we jumped into the implementation phase of our new task, new functionality that we have received, we wanted to break down that large use case that we were supposed to implement into smaller pieces that we can resolve or implement in a less amount of time, to have something that is deliverable and testable and so on. So initially, we started by answering a simple question, and that is, what exactly is a rich text editor? And the answer is pretty simple. It's a list of characters in a specific order, and this list of characters with a specific order is identified by a value and by an index, the index representing the position of that character inside an order list. So pretty much we have resumed that text editor part of the solution as a simple collection of characters which are identified by the character itself and the index, the position. Afterwards, we started to ask ourselves, okay, what we can do with those simple characters? And we resumed everything to two basic operations. And these are insert and delete. And in case you're wondering why I haven't added the update over there, it's because an update is actually a sum of the other twos. So if I have a text editor where I have the word text, if I want to replace any of these characters, it means that I will remove the previous one and add the second one. So update didn't make sense to be treated in a specific workflow. So we ended up with these two basic operations. And yes, we started working on a POC that will allow us to build this specific part. But afterwards, we started to ask ourselves what else we should do with it. What else should our basic collaborative, our basic rich text editor solution be able to do? And we have identified a bunch of advanced operations. And to name a few, we wanted to have everything that Word from Microsoft and many other solutions offered, meaning to be able to apply styling format on those characters, like bold, italic, to be able to put background colors, text colors, everything. So everything that you have in a rich document solution, we wanted to have ourselves. And even more than that, we wanted to be able to work with those advanced objects that I mentioned about, because our users want to simply put the link to some coordinates over there. So we needed a solution to be able to handle links inside the document. We also wanted to embed pictures. We also wanted to embed videos, because our application retrieves some videos filmed by drones. So someone simply wants to put that video inside the document to justify a certain decision. And yes, the picture that you saw over there is from our initial versions of the rich text editor solution. And the last part I have added on this slide is the classification part. And this one highlights the security clearance level of that user. Because as mentioned, we want to highlight it at the document level and inside the document at each individual object and each individual paragraph inside that document, to be able to hide or to remove or to filter certain paragraphs and other objects from there. So, with this list of specification and with the collaborative editor requirement in mind, we started to look at some of the existing frameworks on the market, because you can try to challenge me and mention that this already exists in the market. Why not use something that already exists? And yes, we've tried to do that. And I'll also show you a couple of frameworks, because I did my research and see what is available with this. And there are a couple of names like Froala, CodeMirror, TinyMCA, and many others. And I'll have a question for you. Have you worked with them so far? Okay, a couple of you, so or at least a couple of you knows what I'm talking about with these ones. Well, unfortunately, none of them offered us a solution for the collaborative editing. And I'm going to tell you what. And why. But what we could use was the part for the rich text editor. So just having text inside a single user instance of the document and be able to apply all those styling formats. And the combination between Froala and CodeMirror, at least that worked with our own stack trace, worked fine for us. But not the collaborative part. For that one, unfortunately, we had to implement from scratch everything ourselves. And let me provide some of the reasons for selecting these and removing all the others. The answer lies, of course, in requirements and specifications for most of them. So the first item that in general, so not only in my specific example, but in general, allows us to select or deselect a specific framework lies into the license part. And that is because most of those frameworks and many others that I haven't added on the previous slide have a strange policy in what concerns the number of servers or the number of licenses they are giving you for the collaborative part, because they need a specific number of servers where you are supposed to use the application. And at least in our field of work, we can't just mention we have 235 servers for this specific country navy. And if they have a joint mission with another country, well, they cannot tell the other one, we don't have licenses for you to give because we only paid for this amount of servers. So everything that forced us to give a specific number of licenses, even with some buffers, wasn't something that was accepted by our stakeholders. And not to mention about the support cost, because it cost quite expensive, even more than what it took us to implement a solution in-house from scratch. And this wasn't just the only reason for selecting or not some of the frameworks. Some of them has a rule of forcing the users to share the code that are using their frameworks to the community. And while I'm personally a very big fan of knowledge sharing and sharing to the community, one of the reasons I'm also here as well, well, the policy of the company doesn't allow us to put our own code, defense technology, into a common community repository. We are not able to share it. It is considered high-value code for obvious reasons. So we also had to remove a couple of those frameworks from the list because of this specific reason. And of course, there are even more. The release history, and I'm going to display all of them. The release history was also an argument for this because there were frameworks that didn't have any single update for a couple of years. So we didn't want to take something that wasn't maintained anymore and deal with some deprecation, some removals, or who knows what security issues those frameworks can introduce to our software. And the last one was the compatibility with our own stack trace. Well, we have on the backend side a combination of Java and Scala. And everything we were to choose on the front-end side works perfectly fine with these two. So we didn't have any constraints from the backend side. However, on the front-end side, we have Angular. And some of those frameworks only works with React, which meant that we either change Angular to React and we have a huge application, or we make some workarounds to make the integration work. And we didn't want any of these two situations. So we pretty much ended up with using Froala and CodeMirror for the rich text editor part and building everything on the collaborative side from scratch ourselves, based on algorithms. So I've repeated a couple of times the collaborative editor keyword, but I haven't actually provided the definition for it. So what exactly is it? And we wanted the capability of users that are located in multiple locations to be able to edit the document at the same time. And this also translated into a situation like this. Pretty much we need to have a local copy of the document to be available to each of the user local environment, and the changes that they are making on that local copy on their own environment to be able to get to all the other users that are being connected at the same time. So pretty much the collaborative editor as the keyword suggests, meant exactly this. We have a bunch of users all editing the same document, no matter from what server, what version, what deployment type, but all need to have access to the same information. And this is something that we have achieved through simple notification system, WebSockets, Kafka. This was something that was beneficial for us. But up until that part, which actually is be able to send some notification, we needed to figure it out how to resolve the collaborative editing part. So we started to ask how a solution for this specific part will look like. And well, as developers, we started to look at Git, how Git works, because we consider that it works pretty much the same. I suppose everyone is familiar with Git, but I'll ask anyway. Okay, thanks, everyone. So I'll skip some of the details. So our idea was something like this. Let's imagine that we have a file, version 1.0. Nobody touches it yet. We have two users that they want to make changes, and they want to make changes in the exact same spot in the document. Same line, same column, they want to edit that place in the document. Well, let's assume that the first user is a little bit faster. So if we were to implement a mechanism like Git, it means that that user one would push his own changes, and we will have a version 2.0 for the file. However, when the slower user will have a final version of its own local copy of the document and tries to push the changes, he will get into conflicts. And when he gets into conflicts, like we get when using Git, it means that he needs to fix them manually and then be able to push again, merge the changes, and eventually we will have a version file 3.0 for that document. Well, if we were to implement something like this to replicate what Git does in our own application, honestly, this would have been unusable because nobody wants to be prompted every minute to resolve some manual conflicts. On the other hand, we started to ask ourselves, what if those conflicts weren't meant to be solved manually? What if our system, so our application, will do the judgment behind the scene and fix those conflicts for our users? And the idea was that if something gets wrong, so if our application gets wrong what the user intent was with certain changes, it doesn't matter as long as it is consistent, as long as it applies similar patterns for all the similar situations. And you may think that what I've just said sounds very wrong. And I agree with you in theory, but in practice it works perfectly fine. And that is because the system needs to keep up with the user intent, that is correct, but it needs to be consistent. That is the important part. If it is consistent and applies the same rules in all similar scenarios, then we will always have a consistent copy of the document. Everyone will see the same version of the document, and if something went wrong, then one of the users can simply fix it manually. And that was a workaround that was accepted for us. And no, we haven't implemented Git. And I can tell you that we had even worse ideas previously. Our initial idea was to simply log the document, allow one user to make changes, he will unlock the document, and the others can edit. No, that wasn't a solution for sure. This one looked pretty much similar, but no. So, what we have ended up with, more on the collaborative side, was to define it through two keywords, consistency and responsiveness. So that document, as I just provided you as an example with all my theory about Git, the document needs to be consistent and to keep up with the user intent. And I will explore more into the consistency part, as that is the important one and the one for which we needed to implement a bunch of algorithms. So let's take an example. And from now on, I will have a couple of examples for you. So at the beginning, we have two users, user one, user two. And we have an empty version of the document. Nothing is actually written there. Let's assume that user one wants to type in the document the word collaborative. So his intent is to have collaborative in his own version of the document. User 2, however, in the attempted document, so editing the same document at the same line, line 0 which was empty, wants to type in the word editor. He wants to have editor inside the document. Well, they are working at the exact same time, at the exact same location. So eventually, the two versions or the version of the document, the final one, needs to have both words inside it. And in this moment, it is important to define a rule. Who will be the first user that of which changes will be applied first, the user 1 or user 2? And yes, we are dealing with timestamps and a rule like last man wins. This is something that we have based our entire solution on. So at this moment, it is important that both of them see exactly the same. If it is collaborative editor or editor collaborative, that's something that the algorithm needs to explicitly set as a rule. And yes, as mentioned, our rule was that the first one who makes changes will get his changes go through and implemented. And if someone will override something, then last man wins, as mentioned. If it is possible for us to merge everything, we will do that. And I will have a bunch of other examples to show you how we are dealing with all of this. But how about those conflicts? Because I mentioned explicitly that they are working in the exact same location. So how we should avoid not prompting the user to manually fix how exactly does he want to have in the document, editor, collaborative, or the other way around. And for this one, we have started to look at how we can see the user intent better, so the responsiveness part. And we wanted to be able to compare a bit the initial state and the final state that will end up in the document. And yes, once again, we have looked at what Git is offering, and in particular that Git diff output. But if we were to look at this, it just says something like line 1 was changed from this to this, but it's hard to see the exact intent of the user. What did he wanted to insert over there? What text, at what position, what length, where exactly in the document? And a lot of other details starting to pop up when we have looked at this. So we started to think even more about this, and eventually we ended up considering defining our own JSON objects. We call them actions, operations, but we started with something simple. So we want to see exactly what was the type of the operation, and remember those two basic operations that I mentioned about at the beginning with insertion and deletion, where afterwards we wanted to see exactly where in the document we are inserting, and in this example it's on position 14 where we are putting the text editor. And this one I have simplified a bit, that I'm inserting just the word editor, but in reality it depends on how fast the users are typing, because if they type one letter, they wait a couple of seconds, another letter, and so on, we are not waiting that much time. We are sending the information in a very small amount of time. If they type fast enough, then indeed we are putting a word in there. But we started with this basic object to be able to send the operations that the users are performing inside that document. And it pretty much worked well. And I'll give you an example of how it looks with this object. So, as mentioned, let's assume that user 1 was the fastest, or one of them was the fastest one, and we have ended up with collaborative word inside the document. One of them inserts, taking into consideration that object, inserts editor on position 14 to have collaborative editor. I did mention that we are sending notifications with these actions, so the other users that are connecting, they will all receive a notification that apply this operation of inserting editor on position 14, and on their own local copies, the ones that they are looking at their applications, they will also see collaborative editor. Do you think that at this moment we have the solution? I see some of you are nodding. No. This is not the solution, and that is because nobody is actually trying to introduce some conflicts in here. Someone inserted editor, and all the others were simply looking at the application. So nothing was actually happening in terms of conflicts. So yes, If no one else touches the document, or at least not touching it in that exact same location where someone else is making changes, then yes, at this moment, we were having a collaborative editor solution. But the reality is different. And let's return a bit with the consistency part, and this time with a simplified object, so that you can see exactly what I'm referring to. Let's start with two simple characters, A and T. And we have the indexes to be easy to follow. We have two users, left and right. The first user inserts C on position 0. So his intent is to have the word cat inside the document. Simply so far. The other user, however, inserts R on position 1. So he wants to have art written inside his own local copy. Then we start to get notifications. So user 2 will receive an update like insert C on position 0, and he will end up with a cart. Fine. Do you think that when the other notification will be received, we will also get up with a cart? No. We'll end up with something called CRUT. And I'm not sure about you, but I have no idea what that is. And that is because we are not actually changing that index. So one of the updates, one of the operations was faster. So we ended up with cart already. But when we receive the other notification to insert something that makes sense and it's the same as for the other user, we are keeping that index, that numerical index of that character inside the list, which says insert R on position 0. And it messes up with what the user actually wanted to insert over there. So at this moment, we can assume that the consistency rule that I've been talking about in the last minutes is broken. And let me give you another example. Let's start from cat this time. Let's assume that the first user wants to delete the first character. So his intent is to go back to A and T, the first two letters that we had. The other users does the same, remove first character from that text, from cat. But we will continue to get the notification and we will remove even more, because nobody actually checks that one of the operation was applied, and it will continue to delete from our sequence of characters. So we will end up with a T, and this wasn't none of the user's intent. So once again, the consistency rule is broken, both for an insert operation and for a delete operation. So at this moment, we started to think of other things that we need to consider to make sure that our document is consistent. And at this moment, we have started to think of two mathematical concepts, which are represented by commutativity and idempotency. And I will give you an example for both of them. By commutativity, it means that the same operation should produce the same result, no matter the order, like summing up A plus B, which should be the same with B plus A. So a basic operation mathematical could save us the previous problems that we had. And the second one, idempotency, means that a repeated operation should produce the same result no matter how many times we apply the same operation. It's like multiplying A by 1 multiple times. It will always have to result in an A. So these two mathematical basic concepts are the ones that can help us solve the previous problems that we have. And these two are given by something called operational transformation. And yes, there are many other alternatives to OT algorithms, to operational transformation algorithms. But at that moment where we are under pressure, under a huge constraint of delivering the future on time, we needed to pick up something that was easily to be understood by us, something that we had already acknowledged. And operational transformation was the safest and the easiest choice that we have made back then. And we have built our entire text or collaborative text editor infrastructure around this concept of operational transformation. And it's purely an algorithmic solution with a lot of rules, because it is based on a set of operations, and all those operations are relying on that numerical indexes for the position. So pretty much operational transformation, when we think of the terminology, it means that we need to transform those indexes before we start applying the operations that rely on those indexes. And let's see how this one, this part that I've just told you about, can solve or will solve our previous problem. So remember those two letters, A and T, for the commutativity operation, the first one. User 1 inserts C on position 0 to end up with a cat. The other user inserts an R on position 1 to end up with an art. Previously, we have seen that the position doesn't change. This time, with our rules, with our algorithms, then we are checking where exactly do we need to insert R. And for this one, to answer this one, we started to look at a bunch of other things, like the total length of the string, the left and the right position of the previous characters where we are making the insert, if the operation was already applied, the timestamps, and everything. We started to check a lot of other parameters, like the ones that I have just listed. And eventually, we define or we determine, we transform that index where we are supposed to insert R, and that will be on position 2. And we can already see that we have solved the previous problem, because this user, the left one, was the one with problem. The other one, we applied the same logic. Where we are supposed to insert C, it was on position 0. But if someone would have inserted in the meantime something on that position, we were also having to look at what was the total length of the string. Was C supposed to be inserted before A or before something else? So we are looking at all these aspects. But this, with what I have just mentioned, our document is now consistent. And let's look at the other example for the delete operation with the idempotency part. So we have removed the first character. Both of the users removed or tried to remove the first character. And previously, the notification went through and reapplied the same operation and deleted even more than what was supposed to do. But this time, when we are receiving the notification, we are actually checking if that operation was already applied. And yes, we even play around with having that the same character in a lot of instances, like A, and started to delete each of them to see if our rules of our algorithms are still stable enough to cover everything that the user can play with, because we made the assumption that the user will try to break our application. So we started to look at all these aspects and implemented a lot of rules. And yes, it took us a couple of releases until we made it right. But strictly speaking, for this example, the operation wasn't applied, is not applied anymore, and we end up with A and T. This was both of the users' intent, and our document is consistent. So at this moment, yes, we have a collaborative editor solution with simply applying operational transformation against those indexes when we are receiving the notifications that we need to apply from other users. And I'm not just speaking about 2 users, I'm simplifying things here, but we have a lot of users, so we are receiving a lot of notifications, and we need to check all of them. But up until this moment, yes, we had a solution, but it wasn't enough. And it wasn't enough because there were a lot of other requirements, and all of them represented some challenges, and all of them had to be fixed and embedded into our previous solutions to make those algorithms still work. And we even had problems when we were trying to bring some new rules, because we were breaking others, and we need to make them stable. And let me give you some of the examples for these special requirements. So first of all, so far I've been talking about text, simple text addition inside the document, but I've told you from the beginning that our users wanted to be able to handle advanced formats, advanced objects. And I have screenshots as well of over here with some lists, a table, links, lists, 2 different type of lists. So we wanted to be able to handle all of this, plus the picture part, plus the video part. So we started to introduce the concept of advanced object. And we also started to introduce different type of operations, not only those based on text, but only based on objects. And those objects are of different types. So we have extended that basic JSON format that I've showed you from the beginning. It didn't just had those 3 items. It had them at the very beginning, but we have built on top of it. And let's take an example, because these ones also have some special rules. So let's assume that I think I showed you too much from the beginning. So we have 2 users, user 1, user 2. The first user had only item 1 initially on the list. Second user had item 1 and introduced item 2. Up until this moment, we know that both of them will end up with item 1 and item 2. We have seen this so far. But user 1, not only that user 1 simply sets a list, and it sets a list of bullet list. However, the second user, not only that he added that item 2 on the list, he also applied a styling format, but not as bullet list. He wanted to have a numbered list. So at this moment, the question is, how or what are we supposed to display in the document? Is it a combination, a mix between them? Or is it the bullet list? Or is it the numbered list? And this fall into that category that I've mentioned about last man wins. So if the user 2 was the slowest one and he applied an ordered list, then we will have an ordered list. But we didn't want to get into the first scenario, to have a mix over there. That's the tricky situation. That's the dangerous part, to mix up and to break what should happen inside the document. Because from a technical perspective and from an operational perspective, we can't mix these sort of things. And there are even more types of advanced objects. And all of them were possible because we relied, after we have introduced the concept of complex data structures, as we call them, we rely on the fact that HTML is a tree-based language, so it helped us a lot with all the tree, with the DOM parsing and so on. And this helped us with the tables and images, but also with other sets of operation, because we didn't just want to have lists, headings, and so on. We started to define other categories of operations. To name a few, we have rename operation. So for example, we have a list at the beginning and we want to change it into a heading. We need to apply the same to all of them. Or we want to split a paragraph. Let's assume that I'm in the middle of a paragraph, I press enter, I will have 2 paragraphs now. Or the same applies for heading and so on. And this falls into wrapping and the wrapping operation. We have defined this one as well. And as mentioned, we have differentiated between text operation and object operations. And last but not least, we also had to deal with what we called marker operation. And that is because we want users to be able to search inside the document. And when they want to search, they also want to see inside the document the highlight of the words or the characters that match some of the text inside the document. So we had to be able to display those search characters inside the document. And not only to search and to mark the found text, but we also wanted to be able to display the users that are available or are locked inside the document. But I'll come back to that one in a minute. So now, as mentioned with the users, I gave you a spoiler. When you are working on the document and you have 1,000 users connected on the same document, you can simply have a picture inserted in the middle of the row where you are typing something. And we wanted to prevent this sort of situation, at least to be able to know what to expect and where and who else is working on the same document as you. So imagine my first scenario. Let's assume that I was working inside that text and editor and someone simply inserted a table inside that document. I didn't want that table there and I wasn't expecting that table there. However, if I at least display who is logged and where exactly his cursor inside my document is, at least I know that at that place between text and editor, I can expect something to happen. And yes, we have implemented this and we have called it cursor synchronization. And I'm saying cursor synchronization because it's not just displaying them. It's also moving their position inside the document if something happens. For example, if a user is right between this test text and someone inserts a table inside it, I also have to move the location of where the user is inside the document to still match where it was supposed to be. And I will give you a proper example now. So let's take this card as we have played around with it. And hopefully the colors are well seen. I have an orange and a green highlighting the two users. So the first user has his cursor right before the character A. The second one has the cursor right before the character R. Our object has also been extended to display where exactly we have the users. And yes, if we have a lot of users, we are keeping up information for all of them. We have to do that. And let's assume that someone inserts an H on position 1. So he simply wants to have a chart over there. However, that H is right before both locations of the users. And you can already see the colors that I have shifted the colors. This is exactly what we are doing inside the document. If something appears right before their cursor inside the document, we are also shifting that one. So pretty much when we apply those algorithms, we also have to take into consideration this one and move them when we are sending the notification. So if we have a lot of users synchronized or working on the same document, we also have to deal with this part as well and move, be able to highlight their new location, their updated location. And this was just one additional requirement. We had more. Because at some point, people started to delete things from the document, and all the others were simply asking, where is my text, where is my picture? So we started, and obviously we were forced to do this, to implement a simple undo-redo mechanism. And for this one, it wasn't just, okay, a one-time only. If they are playing around with a do-redo and so on, we also have to support all of this. And that is because, as mentioned, if someone had something in there and removed, we want to be able to bring it back. And for this one, we have implemented a stack manager for undo-redo operation, which look pretty much similar to this one. Let's take that cart example again. Someone inserts the H on position 1 to end up with a chart, which means that that operation, insert H on position 1, is being reversed, so inverted, which results in delete H from position 1. It is pushed into our undo stack where we are keeping the information. And if someone hits undo, then we are once again reverting the operation and persisting. And in case we are playing with all those indexes and something happens, we also need to keep this one updated to be able to reflect the reality and to be able to undo something that still makes sense for the operations of the user at that specific moment. So we had to deal with all of this. This is why I mentioned that they came with a different challenge. And lastly, a last scenario. This is something that we were supposed to do recently. I think last year we have implemented this part. That classification thing that I mentioned, because the information in the document must be displayed just for the users that are supposed to see them. And this matters for the document itself, and I think I have a couple of screenshots. Yes, it reflects for the document itself that square with rest from restricted, just an example. And also inside the document, and here I just have a heading with restricted information, this one also has its own level of classification. So inside a certain document, inside the same version of the document, we have different security clearance level. And we had to introduce this in our own data model and to act accordingly. And yes, we have the access restricted, privileges, roles, and so on, plus this part as well. And I think we have all seen some movies where some documents had some black redacted parts were mentioned confidential. where when we received this requirement, we also imagined all those movies that we have looked at. And we had to implement something similar to be able to restrict the information, not to be visible, but not to actually delete them from the document. So they are still in our database, they are encrypted, nobody can actually steal them, not even for REST API or something similar, but they are not visible to the users that aren't supposed to see them. And we have workarounds to handle the large gap inside the documents. And yes, we have some black images redacted instead of a document, or instead of a picture, sorry, or instead of a video. If it is a heading, a paragraph, and so on, we have a black background with white text mentioning that we don't have access to this because your confidential is set to his level of classification, and so on. But someone with superpowers of seeing everything in terms of security, yes, has access to the entire document and can change the classification of each of the section if something became less restricted than it used to be. And no, in case you're thinking, what if none of those users are locked anymore, we are simply losing the information, we still have possibilities to grant users, from admin's perspective, the possibility of changing something. So our users have all the requirements or everything, all the functionalities in place to prevent a situation in which nobody has the restricted access necessary, so we end up with a black redacted document. This didn't happen. But this was the last scenario that I wanted to present. What I can maybe say even more than what I've mentioned is that our biggest problem was when we were dealing with disconnected environments. I mentioned the air-gapped part. Maybe I didn't insist on the disconnected environment. Because if we have 10 servers up and running and people making changes actively inside the document, and there was one server that was closed just for monitoring operation, and some of their users, I don't know, an intelligence officer or someone simply writes information inside that document, when that server is eventually connected back to the network, everything needs to be in sync. And at that moment, we didn't have any alternatives to merge everything ourselves, but at some point where that is not possible, we are still prompting the user, the one that connects to the server, some of the conflicts that he needs to accept if he wants to put them inside the merged version, or if he will lose some of the information. And we are even dealing with with documents that no longer exist when that server gets restored in the network. And that is also one of a manual choice. If the user wants to still recreate that document inside the network, if the initial document where he kept writing no longer exists. And the situation can also be escalated in case that intelligence officer doesn't have the proper permission to mention that, yes, I need to replace everything you have in the document, or we need to recreate the document, or we need to delete that document. Then it also gets escalated in the chain of command, and someone needs to approve all the changes. So we do have some manual conflict resolution. But except for this situation with disconnected environments, everything is pretty much done automatically behind the scenes in our own algorithm, operational transformation algorithm solution. And with all of this in mind, we have a few minutes for questions if someone has some curiosities. Sorry. Oh, I didn't meant for that. Yes.
Do you need a central part to the whole system, or can it be completely decentralized?
So your question is if we have a centralized server or everything is pretty much disconnected. The answer is pretty much everything is disconnected. So each of our nodes in the cluster setup can be a central server for his own. But yes, users from all the others are connecting to that one. So in one server, we do have the source of the file, but when it is synchronized, it is pretty much stored on all the others. So everyone becomes a master or the owner of that specific document. Thank you for your question. Anyone else? Yes.
You mentioned that some aspects are classified and encrypted. How do you manage all this key horror, key exchange, key encryption keys and things in your system? Because it can be quite complex.
Yes, your question is how we are dealing with all the encryption because it can be quite complex and it is quite complex because of the air gapped environment part and working with interoperability protocols, we have security encryptions in place, and yes, everything is decrypted on the other side when the information gets there. So it's pretty much following the same principle as all the other servers. Only that we have some interoperability protocols that come with additional layers of security.
But the encryption was on the system level, or was it like defined on the user level?
No, it's on the system level. It's not on the user level. It's on the system level. Thank you. Yes. Your question is about backwards compatibility. We have a policy of maintaining compatible ourselves for 2 years. And I can give you an example because it was almost a 2 year gaps between when the moment when we had tables introduced and when we are synchronizing documents that in one place they were having tables and the other one didn't knew how to translate the tables. We pretty much displayed all the information from the table on those specific amount of lines with some tabs in between. So we pretty much translate it into something that can be understandable on the old systems. So we had to do a lot of workarounds to work with this. The simple part was with the picture because nothing was actually displayed on the other side, just some empty lines matching the size of the file of the picture. Thank you. Anyone else? Yes. What we are using. So your question is what we are actually using for this application in terms of the stack trace, the tech trace, tech stack. Well, on the backend side we have Scala and Java, and everything is built around these two. We used to have a .NET monolith at some point, but we pretty much migrated everything to Scala and Java. We have Microsoft SQL database and Postgres. We also have a Kubernetes with Postgres in place as well for our cluster setup. And on the front-end side, we pretty much have Angular. But unfortunately, we still have some old, very, very, very old legacy written in AngularJS that we are slowly migrating as well to Angular. But pretty much this is our setup. It's a web application for air-gapped environment for defense with this stack. Thank you as well. Yes. If we are allowed to use AI, that's a difficult question. The answer is yes, but with some limits. And we have some very, very strict policy in not making changes with AI. So AI is used for making suggestions, providing alternative scenarios, how we can fix this, or even suggestion like you need to update the unit status with this specific amount of values because I've noticed, I don't know what scenarios, missions what he discovered. But to actually make those changes, that's a big no. It's still the human judgment that needs to inspect what AI suggests, and a human user needs to actually confirm that those changes needs to be made. But for all the other aspects to help our work and provide suggestion, yes, we are using, but we can't use quite all the models. We have problems with that because solutions like Anthropic, for example, have in their terms of services something like their software cannot be used with defense technology. So we are restricted with the models that we can use. So we pretty much have to build in-house, in isolated setup to be sure that what we consider high-value code doesn't get to cloud. Thank you for your question. Yes.
How do you manage deployment into those air-gapped environments?
How we manage deployment in those air-gapped environments, they are manually installed or through some automation scripts, but we don't install them from our side. So someone do need to go into that tank and install our application into their system. So we do have scripts to automate the installation with all the prerequisites and so on, but it's still someone that needs to trigger the actual update and installation and so on. Okay. Okay, and I think time's up. Thank you very much for joining. Hope you enjoyed the session and enjoy the rest of the day.